Hey students, so we are going to read Palmar aspect of wrist and hand from the chapter Forearm and Hand. Let's get started. Features. The human hand is designed for grasping, for precise movements, and for serving as a tactile organ. There is a big area in the motor cortex of brain for muscles of hand. The skin of the palm is thick for protection of underlying tissues, immobile because of its firm attachment to the underlying palmar aponeurosis, creased. All of these characters increase the efficiency of the grip. The skin is supplied by spinal nerves C6 to C8, see figure 7.1a, through the median and ulnar nerves. The superficial fascia of the palm is made up of dense fibrous bands which bind the skin to the deep fascia, palmar aponeurosis, and divide the subcutaneous fat into small, tight compartments which serve as water cushions during firm gripping. The fascia contains a subcutaneous muscle, the palmaris brevis, which helps in improving the grip by steadying the skin on the ulnar side of the hand. The superficial metacarpal ligament, which stretches across the roots of the fingers over the digital vessels and nerves, is a part of this fascia. The deep fascia is specialized to form the flexor retinaculum at the wrist, the palmar aponeurosis in the palm, the fibrous flexor sheaths in the fingers. All three form a continuous structure which holds the tendons in position and thus increase the efficiency of the grip. Dissection. Number 1. A horizontal incision at the distal crease of front of the wrist has already been made. Number 2. Make a vertical incision from the center of the above incision through the palm to the center of the middle finger. Figure 9.14. Number 3. Make one horizontal incision along the distal palmar crease. Number 4. Make an oblique incision starting 3 cm distal to incision number 2 and extend it till the tip of the distal phalanx of the thumb. Thus, the skin of the palm gets divided into 3 areas. Reflect the skin of lateral and medial flaps on their respective sides. The skin of the intermediate flap is reflected distally towards the distal palmar crease. Further, the skin of middle finger is to be reflected on either side. Superficial fascia and deep fascia. Remove the superficial fascia to clean the underlying deep fascia. Deep fascia is modified to form the flexor retinaculum at wrist, palmar aponeurosis in the palm, and fibrous flexor sheaths in the digits. Identify the structures on its superficial surface. Divide the flexor retinaculum between the thenar and hypothenar eminences, carefully preserving the underlying median nerve and long flexor tendons. Identify long flexor tendons enveloped in their synovial sheaths, including the digital synovial sheaths. Flexor retinaculum. Flexor retinaculum is a strong fibrous band which bridges the anterior concavity of the carpus and turns it into a tunnel, the carpal tunnel, figure 9.15. Attachments. Medially, 2. Number 1, the pisiform bone, and number 2, the hook of the hamate. Laterally, 2. Number 1, the tubercle of the scaphoid, and number 2, the crest of the trapezium. On either side, the retinaculum has a slip. Number 1, the lateral deep slip is attached to the medial lip of the groove on the trapezium, which is thus converted into a tunnel for the tendon of the flexor carpi radialis. Number 2, the medial superficial slip, volar carpal ligament, is also attached to the pisiform bone. The ulnar vessels and nerves pass deep to this slip. Figure 9.15. Relations. The structures passing superficial to the flexor retinaculum are: number 1, palmar cutaneous branch of the median nerve, figure 9.16. Number 2, The tendon of the palmaris longus. Number 3, the palmar cutaneous branch of the ulnar nerve. Number 4, the ulnar vessels. And number 5, the ulnar nerve. The thenar and hypothenar muscles arise from the retinaculum, figure 9.15. The structures passing deep to the flexor retinaculum are number 1, the median nerve, figure 9.15. Number 2, 4 tendons of the flexor digitorum superficialis. Number 3, 4 tendons of the flexor digitorum profundus. Number 4, the tendon of the flexor pollicis longus. Number 5, the ulnar bursa. Number 6, the radial bursa. Number 7, the tendon of the flexor carpi radialis lies between the retinaculum and its deep slip in the groove on the trapezium, figure 9.15. Palmar aponeurosis. This term is often used for the entire deep fascia of the palm. However, it is better to restrict this term to the central part of the deep fascia of the palm, which covers the superficial palmar arch, the long flexor tendons, the terminal part of the median nerve, and the superficial branch of the ulnar nerve. Figure 9.16. Features. Palmar aponeurosis is triangular in shape. The apex, which is proximal, blends with the flexor retinaculum and is continuous with the tendon of the palmaris longus. The base is directed distally. It divides into superficial and deep strata. Superficial is attached to dermis. Deep strata divides into 4 slips opposite the heads of the metacarpals of the medial 4 digits. Each slip divides into 2 parts which are continuous with the fibrous flexor sheaths. Extensions pass to the deep transverse metacarpal ligament, the capsule of the metacarpophalangeal joints, and the sides of the base of the proximal phalanx. The digital vessels and nerves and the tendons of the lumbricals emerge through the intervals between the slips. From the lateral and medial margins of the palmar aponeurosis, the lateral and medial palmar septa pass backwards and divide the palm into compartments. Functions. Palmar aponeurosis fixes the skin of the palm and thus improves the grip. It also protects the underlying tendons, vessels, and nerves. Fibrous flexor sheaths of the fingers. The fibrous flexor sheaths are made up of the deep fascia of the fingers. The fascia is thick and arched. It is attached to the sides of the phalanges and across the base of the distal phalanx. Proximally, it is continuous with the slip of the palmar aponeurosis. In this way, a blind osseofacial tunnel is formed which contains the long flexor tendons enclosed in the digital synovial sheath, figures 9.17a to c. The fibrous sheath is thick opposite the phalanges and thin opposite the joints to permit flexion. The sheath holds the tendons in position during flexion of the digits. Clinical anatomy. Dupuytren's contracture. This condition is due to inflammation involving the ulnar site of the palmar aponeurosis. There is thickening and contraction of the aponeurosis. As a result, the proximal phalanx and later the middle phalanx become flexed and could not be straightened. The terminal phalanx remains unaffected. The ring finger is most commonly involved. Figure 9.18. So this was the topic. Thank you so much.